Okay, today we're going to be talking about max and min values of a quadratic. A brief discussion of why we care about max and mins. Ultimately, it comes down to optimization, which you'll be learning more about if you do take calculus in grade 12. But basically, a lot of companies in particular care about optimizing things like maybe they want to minimize costs or maximize profit or maximize productivity. So there's lots of companies and people who care about optimization. So how do we know when a quadratic has a maximum or a minimum? So you already learned about telling whether it's opening upwards or downwards. So if A is positive, then it's opening upwards, which means it has a minimum value. And if A is negative, then it's opening downwards and it has a maximum value. So in general, again, the A value tells us whether it's a max or a min. The H value tells us when the max or min occurs. And the K value tells us the value of the max or min. And just remember that the vertex is at HK. Finding the vertex, there are a few ways. We'll do way number 1 in question 1, and then question 2 will be method 2, and the elusive shortcut will be in question number 3. Okay. Completing the square, you should ideally remember this from last year, but in case you don't, remember we want to group these first two terms together. If there is an A value, you want to factor that A value out, which we'll see down here. And then you are trying to complete the square in that you're trying to have this kind of perfect square. Whenever I'm thinking about completing the square, I think about my goal. My goal is that I want it to look something like, let's put the A out front, ax minus h squared plus k. So I know that the A needs to be out front. I know that I need to somehow make that a perfect square trinomial. And I know that the last number needs to be at the end. So that's why here, if I had an A value, I'd factor it out. Here, I know that this needs to be kind of part of our K value at the end. And then here, when we're deciding whether what we are adding and subtracting, you are going to take this number right here, and you're going to divide it by 2 and square it. And that would be -4 squared, which is positive 16. And then remember that we don't actually want to change the equation at all, which is why we are actually adding 0. Because if we add 16 and subtract 16, we haven't changed the equation at all. So we're just adding 0 in a sneaky way. So once we do that, we now have these first 3 terms can factor into a perfect square trinomial. So this -4 is actually always going to be this number right here, the number that you got when you divided it by 2. If you want, you can always expand this and show that you get these 3 terms here. Now it's just these 3 terms that we factored into this perfect square trinomial. So this -16 needs to be dealt with. It can kind of leave the brackets and join that +1 to form the K value of -15. And there's our vertex at 4 and -15. So down here, we've got some fractions. So we're going to do the same idea. We're going to remember our goal is that we want our A value factored out. So we factor out the 3. Then again, we're going to take our B value right here, or B over A, I guess, and we're going to divide it by 2 and square it, which will give us 9/4. And here, you can see that we have added 9/4 and subtracted 9/4. So we haven't changed anything yet. And we're going to factor that perfect square trinomial. And again, you can see that that is just our value before we squared it. Just like up here, before we squared it, that was the number that went in there. This is a tricky part that is often forgotten is, again, we just factor these first three terms. So this -9/4 now needs to leave and join part of the k value, but as it's exiting this bracket, it needs to be multiplied by 3. So that's where this -27 comes from. And again, we have our vertex there. Here, using a method of your choice, you of course could use completing the square here. You would first have to convert to standard form if you wanted to complete the square. But we're lazy. I don't want to do that. So instead, we're just going to find our x-intercepts, which are at +4 and +6. And we learned this before, where if we find our x-intercepts and we average them, that will give us our axis of symmetry, which gives us the x value of our vertex. So again, I'm taking these and I'm averaging them. So I'm adding them and dividing by 2, and I get 5. But of course, I need the y coordinate as well. So I'm going to sub 5 into that equation, and we get -1. Similarly here, we found the x-intercepts. We're averaging them. And we're subbing in to find our y value. So try to make an informed choice. If it's in standard form, you probably want to complete the square, or frankly, use the shortcut method. And if it is in factored form already, you probably want to find the x-intercepts and average them. Okay, for this one, we are going to use the shortcut method. So the shortcut has pros and cons. One of the benefits is that it is a shortcut for the most part. I would really only use if something is already in standard form, which in this question it is. And I'm just realizing that I wrote the x coordinate, but our variable is t. So the t coordinate of the vertex. So only use this in standard form. Otherwise, it's almost too much work because you'd have to expand it and simplify it and then use this method. So here is our rule, -b/2a, that will always give you the x or t coordinate of the vertex. If you want, you can try proving that. The proof of that comes from actually completing the square. So if you follow the procedure to complete the square with y equals ax squared plus bx plus c, then that will give you your coordinate right there. So using this, we have our a is -5, our b is 40, and our c is 100. So we're subbing this into -b/2a, and we can see the t coordinate of the vertex is 4. So to find the maximum value, again, this is when the maximum occurs. And I knew that it was a maximum because this a value is negative. But we want to know what the maximum value is. So we're subbing it into this formula. And once we do that, we get 180 meters. Because the power lines are 185 meters, we can see that the golfer is going to miss the power lines, which is great. Okay, thanks for joining.